This will be quite a technical talk. Sorry for that. Not much about observation, not much about the results. It's more like some technical changes that I did to the camera system over the last year. So this is actually a lot of time that I spent over the last year. And today I want to present you the outcome of all this. And the name of my title is what does AllSky7 and the Gartner Hype Cycle have in common? So now my first question is, who of you here in the audience know what the Gartner Hype Cycle is? Okay, now I see we have quite some guys who are working in industry, because many guys who are working in industry know about this. In research, probably not so often. I've taken here the definition, say, from Wikipedia, but I also try to explain it in my own words. So if there is a kind of new technology, something new, something emergent, it often follows a kind of cycle. So at first you have some triggers, so some new technology, some new algorithms getting available, and then you have suddenly many applications, many guys who try to use it and to elaborate it and find many use cases, and then you get to phase number 2, the peak of inflated expectation. So you believe, well, this can solve almost everything, you know, and it's really great, and it's in the press, media, and so on. And then we come quickly to phase number 3, which is a throw of disillusionment, because you realize, well, unfortunately, it's not that easy, you know. I mean, what you saw at first, like with our LLMs, probably we are somewhere here in this phase, you think, hey, LLMs, they will change the whole world. But you start to realize, but it's still just a language model, and it cannot do everything. So it's often getting down to here, so it's not covered anymore by press. It's it's hard work. Many things fail, but then over time, all the child diseases are sorted out, and slowly you get to phase number 4, the slope of enlightenment. So you realize, yes, you have the first applications which really makes use of this new technology, and finally we at the phase number 5, a plateau of productivity. So this new technology really has reached our main life, and has really made sensible applications. And really, you see many of these technologies somehow follow this cycle, be it, I don't know, autonomous driving, be it large language models. It's really fancy. I like this model. And actually, in the last year, I passed my own Gartner Hype Cycle. And this is what I want to tell you about in this talk here. So what was my technology trigger? That was actually last year at the IMC in Kutna. That was a talk with Mike and some of the breaks. And hey, Mike, what's up? AllSky7, everything right? And said, yeah, of course, all good. But you know, we have some issue. And this is, unfortunately, the camera positions are not known very well. I mean, you would say that's easy. I mean, just go there, measure the GPS coordinates, but we have like 100 cameras, and the camera operators are sometimes not that diligent. And meanwhile, if we have like firewall observation with 30 cameras, we need to have accuracies down to 2 or 3 meters. That's sometimes an issue. And Mike said, well, if only we had a GPS sensor in the camera, you know. And I said, well, come on, we are living in the 2020s. It should not be too difficult to get a GPS sensor in the camera. Let's see if there's anything on AliExpress where we get most of our equipment from. So this is how it started. Yeah, that was the technological trigger, was this. Such a system, it should have preferably like the 12 volts power supply, because that's what we have already inside the camera. And it needs to communicate, it needs to communicate via Ethernet, because everything else in here, all the cameras are communicating via Ethernet. So I do not want to start now with Wi-Fi or with USB connection. It must be Ethernet. But that was one of the prime criterion. So yes, I did still during the IMC, did some simple search on AliExpress, but unfortunately, I didn't find an out-of-the-box commercial of the shelf solution, which I could just buy and put it in the camera. So here, this was like a screenshot from my smartphone. Yes, many fancy devices you get there, but nothing that fits exactly to these requirements. And that I thought, well, I mean, couldn't be too complicated. Just give it a try. Let's try to do something on my own. But I must say, I'm a total beginner in this. I have never done anything about microcontrollers, about sensors. So it was really totally news to me. But I said, it couldn't be too complicated. I'm a computer scientist, so that should be solvable. So what I did, yes, I was searching like what kind of microcontrollers and sensors are there available on AliExpress, and I have no idea of all of this. So I found out they are really very cheap, and so I just like ordered a mixture bag of all of these fancy looking microcontrollers. So I tried with an Arduino. There's also a nano version of this Arduino, which is good. It's smaller. Then you need to have an Ethernet shield, which you put on top on it, that you have Ethernet connection. There's also such an Ethernet shield for the nano version. This is like how the GPS sensor looks like. Yesterday we have seen one in the Dupont system, probably almost the same device. This is like how a temperature sensor looks like, which you also want to integrate. And then I also find some other fancy microcontrollers with some displays, not really useful here, but still, I mean, I thought I want to try this one. So this is like the bunch of hardware which I actually ordered from AliExpress, and 2 weeks later it looked like this on my table. I had a fancy collection of stuff from AliExpress, and now let's start. Yeah, let's start. What to start with first? Because as I said, I have no experience with microcontrollers at all. So what did I do? Ask ChatGPT. ChatGPT, I'm a C programmer. I have here some device and I want to like connect the GPS sensor and the temperature sensor. What do I have to do? And the answer was perfect, you know. Tell me, okay, you have to start with, okay, this is the hardware. You have to install IDE. You have to install certain libraries step by step. Perfect, perfect explanation. And so this is actually, I think, now we are at phase number 2, because believe it or not, it was just a question of 3 hours in one afternoon. 3 hours, starting from zero, where I installed the development environment, where I connected hardware-wise the Arduino via USB to my computer. I could install this Ethernet shield. I could deploy a simple web server here, and I could communicate to this device via web server within 3 hours, something completely new. So that was really amazing. Usually it would take, you know that, weeks, months, I don't know, one afternoon. So peak of inflated expansion, hey, that is so easy. That will work out from alone. I was really happy. And the only thing that I couldn't do by that time is already attach the sensors, because I realized I'm missing some kind of level shifter. So for shifting the voltages, I didn't want to wait like for 2 more weeks. So I ordered one. Again, this is just a few euro from Amazon, because Amazon just takes 2 days until it arrives. So then I could really attach the sensors. Phase number 2, right? Well, you know, after phase number 2 comes phase number 3, the throw of the illusionment, because, what I did then in the next 2 weeks was not really good, or did not really work out. So yes, I could attach the GPS sensor, and GPS sensor was sending me some data, but I did not get any valid position, any valid solution. I found out that the Arduino Nano has so little memory. Yeah, I could place a program there maybe of like 10 lines of code, which would be sufficient maybe to read out the GPS. But if I want to do anything else, that's not the right device. So I tried with a little bigger one, the Nano R3 with the Ethernet shield, but then was physically simply too big to fit into my camera. So also not a good solution. The little Heltec device, I didn't get working at all. This was like my setup with try to soldering this thing. You see, this is of course extremely error prone. That's not really professional. Like, so more or less, I was working like for 2 weeks in the evenings, no progress at all. I was still stuck at the same, and you see, phase number 3, I got somewhat frustrated. Okay, so let's get to the next phase, to do it in a more structured way. So then I bought these kind of Dupont cables and these breadboards, and we can plug the things easier together. You do not have to solder it every time. Also, this is an important device here. It's called a third hand. I don't know whether that's also an English term, that helps you with soldering, because if you want to solder something, you have the soldering eisen in one hand, the soldering iron, you have the thing you want to solder in the other hand, and then it needs a third hand to keep the thing stable. I mean, some easy beginner stuff, but I had to learn it. Yes, that really makes life easier. A friend of mine told me, well, I mean, if you're not successful with this Arduino, why not trying with Raspberry Pi, which is also available in a Pico version, a very small one. And again, have a look at the price. So it effectively costs nothing. You can play with that. And what I found actually by searching on AliExpress, well, that is a fancy device, because it has already an Ethernet connected. So it's already a standard Raspberry Pi with an Ethernet chip and with the connecting plug integrated on the chip. Well, that of course makes it easier. So I do not have 2 devices which I have to put together. It's all on one board. This Waveshare RP2040 ETH Costs a little more, costs like 14 euro, but which is still a bargain. And so this is actually the device that I have decided on. It has more memory, not just a few kilobyte. It has like 2 megabyte of memory, which is sufficient to put some code on there and also to store some data. So I'm phase number 4, so things are starting to improve. And yes, things are progressing step by step. So I finally succeeded to attach here. This is one of the real picture to attach the sensor and also read out the sensor. I could step by step extend the software. With the help of ChatGPT again, I also was finally able to solve my GPS problem. Solution was very simple. The orientation of the antenna is critical, which I simply didn't know. So it has to be really in a vertical orientation, and then all of a sudden you get a proper signal and you get also a proper position. And then I did like really the first prototype that I soldered like on this kind of Euro card, and the soldering alone took 2 hours. So it looks like a small device, but yeah, all this nitty gritty soldering, it's not that easy, probably not ready for mass production. The last step, I mean, once I had this prototype, I also need like a special cable, which was again manufactured in China to actually connect this Raspberry Pi with the Ethernet connector to my Ethernet router, which is or Ethernet switch, which is inside the camera. So that like was more or less my first functional prototype. This is obviously not inside the camera, but this is how it would look inside the camera, connected with Ethernet on the one hand, getting electricity 12 volts on the other hand, and here's a little GPS sensor. So I was, yeah, I was having a prototype which would deliver the GPS position via Ethernet, via some HTTP call. All right. Now, that is a prototype. So how do you get from prototype to a serial production readiness? Because in the end, I want to deploy many of these sensors, like in many AllSky7 cameras. So I cannot solder this board like for 2 hours. We need like a professional solution with a PCB, with a printed circuit board. And I said, oh, Mike, you have done that before. Please do it for me. Design this printed circuit board. What was Mike's answer? Well, that's easy, you know. I mean, do it on your own. There's this easy EDA software. You can do it on your own. Yeah, again, it's the first time. The learning curve is extremely steep. That was 1 weekend for me. And I learned, all right, there's like 3 phases. The first phase, you put down your circuitry, like on with this program. On the second phase, you place the components on this board, and then in the first and then third stage, you route like all these connections between the individual elements. And in the end, once you have this, you send it to the manufacturer, I mean, who is giving you the software here for free. And then the price again is ridiculous. It's for €1 per piece. You get then your custom-made PCB. So this is, it's amazing. These times, it makes it too easy for you. So then the minimum order is like 5. So I ordered like 5 of these boards and gave it a first try now, not having it soldered on my Euro platine, but really having it on a custom PCB. So yes, now we are slowly reaching phase number 5, the plateau of productivity. So this is what I got like 2 weeks later. These are the custom PCBs designed by me. And so I put like all the components in there. And already by doing this, you see this is the integration, how it looks like. So the green thing here is the sensor board is just put below the Zenithal cameras. And already by doing this, of course, a number of new ideas came up, and I got hints from other colleagues who have more experience than me, like, okay, if you put a sensor inside the camera, temperature and humidity, it will also be helpful to have another one outside, because then you can measure like what is the difference, like how does the camera behave, how much does it heat, what about humidity? Yeah, okay, I mean, this board has still plenty of free ports, so why not adding just a second sensor for getting the temperature and the humidity outside? The next thing, why not putting the relay here? So for example, if it's getting too hot, that maybe you can like trigger it by the internal conditions, some little fan, which hopefully would create some cooling, or the other way down, if it's getting too cold in the camera, that you could like start a heater driven by the inside sensor. So that would be good to have simply a relay. So that's now an optional thing that you can attach. You need to have something like a ground plane I didn't know of. Now I have added that. And then I also yeah, while attaching it, I found, well, the components are not perfectly placed. So I did a second revision of the design of this printed circuit board, where I also placed the components in a little better fashion so that it would easier to be mounted inside the camera. So then while the new order went to China, the revision 1.1, and I got the new printed circuit boards, there was sufficient time to also take care like of the software. So what I've implemented is like a simple HTTP web server on this little Raspberry Pi device, which has some basic functions to read out the sensor data, of course, to make them available. It has also some configuration methods, like if I want to configure, for example, the relay, that it starts at a certain temperature and stops at a certain temperature, then this should be easily configurable. The whole thing is a black box. It's not like a Unix server where you can connect to and can read out sysocs. It's a black box, and in order to debug it, to find problems, you have to implement your own logging function. So this is also what I did, because of course in the beginning there are many problems you have. And with this logging and debugging, I find out where the problem is and I can solve this. So this was part of the software. Since there is sufficient memory on the device, I could also do some buffering and storing the data so that I can not only access them in real time, but I can store them for a few days and read them out later on. I have implemented, that's an important piece, a remote software upgrade solution, because once this board is installed inside the dome, of course, it would be hard to install a new firmware version. You would have to open the dome, attach a USB-C cable, so it should all work via the Ethernet connection. So this is also meanwhile working, including some helper functions. I had some issue with the communication from my Unix computer, from the AMS computer to the system. I found a workaround for that. Meanwhile, this is already like 2,000 lines of code, so it's longer than I expected in the beginning, and it's all C programming. So this is my very first programming language when I did my computer science studies 25 years ago. Now they are revisited with this project, going back to the roots, going back to C programming. And now we are at the serial production phase. So this was the first batch of sensor boards that I have implemented now that I got the new revision, the improved revision. I manufactured a batch of 10 and integrated the first of these boards into real AllSky7 cameras and brought it really tells you about the details, how this board is working. You see, this is also one of these things we have the relay attached just for testing. And now let's see how the things work out in real life. Yes, of course, there are child diseases. So something which you do not see as long as the thing is at your table, which you only see if the camera is out and then for some reasons not working. So these are a number of child diseases that I came across and that have meanwhile fixed. So in the beginning, for some reasons, the outdoor sensor was simply not working. So it was working as long as I was inside, but as soon as I had attached it to the camera, I got no signal. And it took me indeed like a week until I found out that there's some short circuit by the way that I mount the sensor to the camera. That was not obvious. Okay, but as soon as I found it, I could fix it, and now I got the camera working. Also, the GPS sensor was not working properly. What I learned is really that it's a very delicate thing to attach the antenna to this little sensor. It's just something you have to drop on it, but it's really a delicate thing that I learned. So now I learned it. I can pay attention to this. I found out once it was out there that after a few hours, it stopped working. Yeah, it did not send me any data. So what's going on? Okay, get it back, try to debug what's going on. And what I found is, yes, I have some function call inside the software. As long as you do it like for 10 minutes, it's fine. But each time it was consuming a little piece of memory, and after 4 hours, the memory was full. So I had to fix this piece of code. Then it was not just working for 4 hours, it was working for days. I learned the hard way that if I touched 2 pints of power, the external power plus USB, it would burn the thing. So should do that again. I put a big warning on our page. And yes, I also, something I recently learned, that the outdoor sensors, the one which is mounted outside the camera, we should also select another one because that one is not really weatherproof. And the last good news was finally, once I did an upgrade of the operating system version of the AMS computer, all of a sudden one of my communication problem was gone. So this is actually not a problem of me. It was a problem of the Unix kernel, which is somehow really deep in the technical stack on how it's communicating. They have fixed something, and that actually helped me in the end. And then, as always, further ideas. So it was actually Mark who said, Marcus who said, well, you know, I do have, beside my AllSky7 camera, I do have also a sky quality meter, and I have also an air quality, so some dust measure. Could you integrate these into your sensor board? Yeah, sure, why not? This is actually what I've done lately. So this is a little sensor, again, the price €1, which is in every of these sky quality meters, and which I have now integrated into the camera. So now we also have like the measurement of the overall sky brightness, and this is a little bigger one. And this is also, I mean, causing some headache to get this big device into this enclosure, but it also worked out. This is like this air quality, so it also measures, has nothing to do with our meteors, but anyhow, it was requested, so why not doing it? And actually, the last idea came from Daniel, which is not yet implemented, but I will also like implement a simple LED, which gives you for the 1 PPS, which gives you a pulse like once per minute, and then you have like a short like light flash in all of the videos, and that might help us to synchronize our videos to frame accurate to a millisecond. So this is not yet implemented, but it's just a few lines of code. So this is the current status. It's up there. It's the red curve is a temperature inside and outside the dome. The blue curves are the humidity. I calculate the dew point, which is helpful, especially for these cases where the camera is having dew problems. Middle part, that's a GPS position. I don't give it an absolute value, but in relative value. So you see that it somehow, changes, that there is some noise. The blue dots or the colored dots are giving the longitude, latitude. And down here is the sky quality meter result. So obviously that gives us only result at nighttime, and also the dust concentration sinks. And already, like from looking at this, we had some first interesting findings. So, for example, what's interesting for us is like the difference between the inside and outside temperature. Why is that interesting? Because we have a chip in there which cuts everything at 60 degrees centigrade, because we do not want to damage the camera, and if it's getting too hot, then it is shutting it down. And we see that the temperature difference is like more or less constantly 15 degrees, which means as soon as we have like 45-degree outside temperature, it will get to 60-degree inside the camera, and it will shut down. So this gives us an indication if we have some real hot summer days, we are reaching the limit and we have to take care of cooling of the cameras. Otherwise, it will get too hot inside. The second interesting insight is about the correlation between the humidity inside and outside. Usually, we want to have it dry inside the camera in order not to have these dew problems. But in particular with this camera, we see it's nicely correlated. So I need some better insulation so that it really stays dry inside the camera. And the third interesting thing, which Bernd actually found out, if you look at the pattern here from the longitude, latitude, it's not really random noise. And you see the scale is like 2 meters, 4 meters, that we see some effect that in the evening hours, we are measuring positions which are a little more north, and then in the daytime hours, a little more south. Don't ask me why. Bernd is more an expert, also has no idea why, but it's interesting. It's something we will close a look at. We see this with every camera. So there's not just one camera. We have meanwhile deployed about, I don't know, 5 cameras, 10 cameras, which have this GPS sensor, and we really see like a daily pattern of the geoposition. All right, so I think that's that's my last slide. So from now on, this kind of sensor board, which also have somewhere in my jacket. So this is how it looks in reality. If you're interested, you can have a look later on, and it says defect. So if you don't take it with you, I don't mind, because something is going wrong with this one. I will integrate this board now in every new camera. We have solved the initial problem, the initial question, which was, please give me the accurate GPS position. So that will be available for every new camera. The sensor board has meanwhile augmented by different additional functions, and you have further ideas. We can easily integrate them as soon as we have still 3 pins on this Raspberry Pi. The most important, the firmware upgrade can be done remotely. I can really control everything from remote. I can deploy a new piece of software without someone have to climb the wall or climb the roof, open the camera and attach a cable. I hope that most of the child diseases are cured. There's currently still something I'm working on, some strange effect. So as always, things are still tricky. We have the chance to upgrade existing cameras. It's not that easy. It's really tight. Sometimes it's a question of few millimeters, but I have also upgraded already a number of cameras. And what's still missing is that Mike is integrating this readout of the geoposition into his software, which controls the whole camera. So that's a small piece that he's reading out the information, but it's fairly simple to be done. And as a kind of spoiler, there's also a small spin-off project in all of this, which is called the Health Checker. And this is this little fancy device. And if we have some time later during this conference, I may add another talk of like 15 minutes to tell you about this, which is more like a toy, but which also came into life, named AllSky Health Checker, in parallel to the sensor board. And that's it. Thank you.
That's great, Sirko. Now we open for the Q&A. Is anyone has any? Oh, here we go.
Thanks. Very interesting, Sirko. I have a question regarding the diurnal variation of the GPS. Well, not the diurnal variation, but just a question.
Yeah.
Did you check these data during a solar storm, perhaps? Because then
no,
you expect some
it's a daily pattern. It's a daily pattern. You see it every day.
Yeah.
Maybe if I go back, I mean, you can have a look at these yourself because this data is publicly available. So either you go to our AllSky7 homepage and then you have all these camera. Each camera has a live view. And if this camera has already a sensor board installed, you can click on sensor board and you will see this kind of graph. And the other way is we have like this archive.allsky.dv for each of our AMS stations. You have a subfolder sensors and you have the latest PNG, which gives you this picture with the last 24 hours. Or you have like a data HTML where you can have a look at all the previous days and you will see the same pattern every day. So it's nothing which was specific for one day.
And well, is it correlated to the local? I mean, if you look at different time zones, is it correlated to local time?
I didn't check that in detail. It was just like an observation that you've seen from the color here. I mean, it becomes fairly obvious that the blue colors are on top and the bright colors at the bottom, but we didn't do any closer analysis, at least not me.
Okay. Yeah.
Yeah, maybe Bernd.
One more remark and then we're done.
I'm collecting the data and I will evaluate and look what I can find it. Because first I see it only in one data and the difference, for example, in position were much more larger and at one station and not at the others. I will look at the data closer. So.
Okay, we thank our speaker again once more.